Hey everybody. So I'll pour the cup in a moment. So you have about a couple of minutes before you get your last bets on the tea. Okay, so I'll start the recording. Where's Ob's gone? Afternoon, welcome everyone to the week 4 Programming 1 lecture for 2021 autumn, because this will run in spring as well. We're at this point somewhere in the middle of working with arrays, just starting to use loops to do things. In terms of what you should be kind of reading at the moment, you probably should be up to methods. So let's hang on. Just as a recap, let's see where we're up to. So we're just finishing off the week 4 lab. Obviously, for those guys who have it this afternoon, you'll be done then. The solutions are available. Yeah. So you should have seen arrays and loops, and you should be starting to read the methods and stuff. You won't need that for next week, but it's probably a good idea to begin looking at that just to start to get a bit of a handle on it. You've actually been using methods already so far, so again, it's another thing which is probably going to be scary and confusing, but it's a thing that you've already done. So if you try and relate it to the bits that you've already done, you'll have a little bit of an easier time with it. Okay, let's go back to the workspace. So what I want to talk about this week is a little bit more about technically about arrays, but I mainly want to talk about loops, make sure that we've really covered that because they're such a central component to it. Talk about some of the variations in loops and maybe show you, so it's in the lessons, but maybe show you some of the kind of dumb and strange things that you can do. So a bunch of the stuff that I'm going to talk about there this week probably won't turn up in your assessment tasks. But if you have them somewhere in the back of your mind, they're a thing that you can do, and they can help you get a feel for how these things work. The other thing, so if that doesn't take me too long, I will start to talk a little bit about methods. That may involve a diversion into how Java handles memory, because once you start using methods, you have to start thinking about where variables are stored and how information flows around. Again, there's a lesson there, but it's probably worth me kind of doing it live as well, where you can ask questions. Don't forget also, unlike me, that there is a question thread on Ed. So if you've got questions arising from the lecture, as usual, over in the week 4 section, there's this live video, so let's not play it, but there's a question thread. So again, everything from the lecture should be in this one spot. If you ever forget where it is, just go to that bit and you'll find it. One more thing that I want to bring up. So someone here, I won't say who. That's not important. They're not going to get punished for it or anything like that. Posted code from an assessment task. Please don't publicly post assessment code. You can post on the discussion board, but you have to make it a private post. Okay. So it's all right to show the staff, but don't show other students. So I deleted that. If you're not happy with the answers that people came up with there, post another private question and the staff can answer it there. Okay, the most important question of the week: what tea am I drinking? So anyone who said anything fruity or chamomile, you're all wrong. I very rarely drink fruit-based teas. Never drink chamomile. As you can see, it is a black tea. So I didn't go for green this week. It is Sydney breakfast. This is like a light Earl Grey. Yeah, so let me just put the question thread down there. That one's resolved. Okay, so on to actually talking about some programming. If you want to know where I buy my tea, post a question in the lecture thread. Let me import the scanner just so I can. Apparently my typing is all over the place today. Okay, so again, another thing, so I'll keep reminding you until everyone kind of does this automatically. Don't forget that you can actually jump into the workspace here, so you can see the workspace in your browser window, rather than trying to watch it through the YouTube stream. So the YouTube stream is fine later because you can watch it back on high def, but in the streaming one, it's probably not super visible. The recording I make is in high def, of course, so it's recorded okay, but yeah. If you come and watch it in there, you can watch me type. And you can fork it later, of course. Sorry, it's the wrong button there. You can fork it later and mess around with it, or you can fork it in the middle and mess around with it. Right. So, what do we want to talk about here? So, actually, I think I want to take a little bit of a step back and emphasize why we use some of these tools as we do in programming languages. So things like arrays and perhaps data structures you'll see later. I mean, definitely data structures you'll see later at some point in your degree, but maybe by the end of the subject. And things like loops, and hopefully if we get to it by the end of the lecture, methods, are all ways of not having to do the same thing over and over again. Because if we have to do the same thing over and over again, one, there's not, like manually do the same thing over and over again, one, there's not a lot of point getting a computer to do it because we could just do it ourselves anyway. But more importantly, from a software design kind of point of view, is that if we reduce the number of places where a thing occurs, and that's very vague language there, but if we reduce the number of places where a thing occurs, we reduce the sources of error in a program. So you've already seen this before with the arrays. So if I have to declare 100 variables, one, that's annoying, but two, that's 100 places where I could make a mistake. So if I'm going int I1 equals something, int I2 equals something, and then even worse, if I do a bit of it and come back later, maybe I miss one of them, maybe I forget one of them, what one of them's for, maybe I give one of them the wrong value because this is meant to be a 6 and not a 7. So instead of being sort of one thing that could go wrong, it's 100 things that could go wrong, or 1,000, or however many there are. Like even just ignoring the impractical cases. If I type this, int, all of a sudden I've got a single line of code where very, very little can go wrong. It's not that things can't go wrong, but I've reduced the opportunities to make a mistake, basically. So obviously I can get the type wrong, I can make a typo, I can put the wrong number in here, but that's kind of it. As long as I do those three things correctly instead of, well, I was about to say 100, but if I'm declaring 100 of these variables, I've got 1, 2, 3 things for each line, so 300 things. But here, if I do those three things correctly, and I haven't done something correctly there already, then I know I've got 100 int variables. I know what their names are all going to be. I know their names are all correct. I know their names are all different. I know I haven't got like int 1, 2, 3, 4, 5, 6, then 8, 9, 10 or whatever because I forgot one in the middle or something like that. And I know they're all initialized to 0. So that act of using an array, and by using an array, what I really mean is the act of getting the computer to do the tedious work for you reduces the chance for the program to be wrong. And that's pretty important because, we don't want to write programs that are wrong. Because they don't do what you want then. So loops are the same kind of thing. Alright. So I could write A2 3 equals 3, A4 equals 4, and try and assign the numbers 1 to 100 to the variables that are embodied by that array. But you can see, in fact, like completely unintentionally there, I've already made a mistake. I'm 3 lines in and I've skipped one. Because, my brain is working at the speed my brain works and my fingers are working at the speed that my fingers work, which is not always the same. So on a good day it is that, I type reasonably fast because I've been doing it for a while and I think about programming reasonably fast, and sometimes they match up and it's all okay. Other days I haven't had enough tea, or I've had too much, or I'm just tired and mistakes happen. But if I write a loop, let's do it this way. Once again, I've very, very much reduced the basically the number of spots where I can have an error. And thinking about it in the reverse, if there is an error, I only have to look in this one spot now. So it's not that there can be no problems, or there can't be problems, it's that I reduce the places for the problems to be, so even if they are there, I can find them much, much more easily. So again, at the end of hopefully by the end of the lecture, when we've seen methods are a way of doing the same thing. But so again, I'm going to draw a very fuzzy distinction between these things here. Where data structures like arrays and eventually lists, trees, all the other hash maps, all the other things that you'll eventually see are ways of repeating data that does the same thing. And loops are ways of repeating sort of adjacent pieces of code that do the same thing. Methods are ways of repeating a piece of code that is kind of scattered all over the place. So in a sense, the difference between a loop and a method from that perspective is that a loop all happens one after another, where a method you can call it here, and then you can call it over here, and then you can call it here. So you're repeating that code, but at different weird intervals that are just sort of arbitrarily decided. So all of these things that we're doing are all exercises in getting the computer to do stuff because it's better at doing boring drudge work than we are. So what's the next thing we draw out of that? Well, the next bit is sort of how do I know when I want to use a loop? Fortunately, that's reasonably straightforward. If you find yourself repeating basically the same line of code, you should be thinking about doing a loop. And when we see methods, this is doubly so. If you see the same block of code twice, You should probably have a method for it. All right. So that's enough about the sort of high-level design goals. Let's take a bigger tour of what loops can do for us. Or rather, let's turn that around, what loops we can use to do things for us. So far, we've basically seen a for loop. And for loops are fairly straightforward. They have a starting condition. They have a starting setup, an ending condition, and a step. We've also seen while loops. And obviously, if you've read the lessons, you've seen more than this, but I want to talk about the interesting things and where we might use them. So you've also seen while loops, which just have a condition basically, and they continue while that condition is true. Okay. Sips tea. But you can see here, I've just written a while loop that when you put some extra bits of code in it, looks pretty similar to what the for loop does. And this is essentially what a for loop actually is. So a for loop just unravels, or you can rewrite a for loop as a while loop that looks like this. You take this piece of code here and put it first. You take this piece of code here and put it in the condition of the loop. And you take this piece of code here and you put it at the end. And again, like, that's kind of how the whole thing works. And then we get it to print out 1 to 100. Yay! We can get a computer to print out numbers. I mean, that's basically what they do anyway, but that's their whole job. So you can see, hopefully, that while loops and for loops are really essentially the same thing. And the decision to use one or the other is more contextual about the nuances of the syntax than really the process of looping itself. I'll get to the increment thing in a second, actually, because it's a useful thing to know. So you can take any piece of for loop code you see or any piece of while loop code you see and turn it into the other one. That's no problem at all. But where might we use one that we might not use the other? So for loops tend to naturally fit into a situation where you have sort of a well-defined number of iterations. Because you can see it here. When you're writing the for loop, you're literally writing out that header line that says, you know, I'm going to start here, I'm going to end at this point, and this is how I'm going to increment, or how I'm going to step through that range from the starting point to the ending point. Or, yeah, how I'm going to approach it. While loops tend to be more natural when you don't have that kind of defined looping thing. So here, I'm doing something that really should be a for loop. And you might say, well, if they're equivalent, why would you say something like that? Well, again, it comes back to the chance of introducing an error. It's a pretty good metric for figuring out which way you should program something. So if I'm writing out a for loop, I've got a syntactic structure here that prompts me immediately to write out 3 things. So I can write sort of anything here and anything here, but nonetheless, once I've learnt the syntax for a for loop, I come into it with this idea that the thing that I should be writing here is the initial starting condition for whatever it is I'm doing. The thing that I'm writing here should be the loop condition, and the thing that I'm writing here should be some kind of step condition. If I'm writing a while loop, I have to think about those three things separately. Even worse, because we tend to write code sort of as it appears, which is not actually always the best thing to do, but we tend to write it from top to bottom because we read it from top to bottom. Okay, maybe you start off with the initial condition, all right, that's fine. You get the loop condition, okay. But it's really, really easy to leave this off. And then you may obviously guess what happens when we do that. It gets stuck. We're in an infinite loop. Because what's happening is that j is less than the length because it starts off at 0. But at no point do I change the value of j. So let's see if I can actually terminate that. Yeah. See if I can send the kill signal to this at all. No, just have to close the terminal, or maybe even close the window. Getting into an infinite loop is a somewhat dangerous thing to do in Ed, because you've got the delay of going through your web browser, rather than like on a home computer where you've got access directly to the operating system. But you can see, well, maybe you can see that that's a really easy thing to leave out. After you've written 20 lines of code, you can easily forget to put in your J++ or I++ or whatever the increment condition is, or increment step is. And then you get an infinite loop. And if your code is not as blindingly simple as something like that, it may not be immediately obvious that you're in fact stuck in an infinite loop. So if you've got a loop that you expect to last for a long time, so if you're writing something that does some serious data processing, so just as an example, I once had a program that ran, like legitimately ran, and I knew it was doing stuff for, I think I had it running for about 3 months, something like that, give or take. But if you were writing something like that and you forgot to do the proper increment step and you're stuck in an infinite loop, you've sat there, started it running, walked away for 3 months, and then come back and gone, oh, well, that was a waste of time, because it's literally done nothing useful. So if you have a well-defined starting and ending condition and a well-defined step, then a for loop is quite natural because it prompts you to do those things immediately. In situations where you don't, for example, where the condition might depend upon some user input, you can't predict what that value is going to be or what this step is going to be. So the while loop then becomes more natural because you don't have to try and guess anything or set up any weird conditions. So some of you might guess that this is not the best way to do it, but I'm deliberately doing this to introduce something in a moment. So I've got a loop set up here, or I've got a program that is a bit strange, where it's saying, okay, which value of the array would you like to see? Whoops. So, I can ask for what's in 5 and 7, 8, 9, whatever. Number 78, 34, various things like that. But it keeps going until I, the user, not I, the programmer, decide to enter -1. So there's no way to really do that in the natural structure of a for loop. And the while loop is a much more natural thing there. That doesn't mean you can't do it as a for loop. So in a couple of moments, I will mangle these and show you sort of bad things that you can do with them. But this is a good point to introduce the do while. So just as one of our first variants on a loop, you can see a situation like this, and it turns up reasonably often, where I want to do some setup, but that's also the repeated change that we need to do in the loop. Okay, so you can see this exact piece of code is occurring twice. So there is a thing called a do while. That is a special while loop that runs the code at least once. So it's a funny little thing, but it's incredibly useful, because if you know you have to run the code at least once and it turns up a surprising number of times, this is a much neater way of doing it than trying to repeat this code here twice. Again, for the same reasons we had before. Because now, if I mess up this code, I know exactly the one spot that I've messed it up in, and I can go and find it and fix it really easily. Or if I decide to change how it works later on, I only have to go to one spot to alter what it does. Alright, so if I wanted to change what the message was, and how it printed out, I don't have to go and find it in two places. I mean, sure, 2 is fairly trivial, but as your code base gets bigger, you go from 2 to 8 to 100 to something like that. If I actually write the correct thing there. And then we get, apart from me changing the message and the formatting, we get something that works externally essentially the same. Plus maybe some guard stuff. So nothing's perfect, of course. So you can see there, you've got to adjust the code a little bit to make it work. But it's probably worth the trade-off, especially if you were attempting to sort of repeat this code a lot. If that piece of code was substantially bigger than what I've got there. So you have to set things up outside, because if I set the variable up inside here, it's in a different scope. So just as a reminder, because this will probably take a while to sink in, a variable only exists from the point of declaration up until the enclosing close brace. So not the first close brace that you see after it, because obviously it keeps going after here, but the one that's actually, you expect to be indented one, the one that encloses that block of code. So if I declare J in here, this won't even compile. So cannot find symbol, because this while condition is outside this set of braces, but this is inside that set of braces. So for those that are just picking up in little bits of the code, so this condition here just says j is not equal to 1. So a longer version of that code is not. So the exclamation mark is usually not in most programming languages. Python actually uses the word not. So this would be j is the same as 1. So not j is the same as 1. So it's anything other than, not 1, sorry, negative 1. So this is equivalent to saying j is the same as any number other than negative 1. But because that is used so often, there's a little shorthand operator for it, which is the not equals operator. It's an incredibly useful one. Okay. And speaking of little operators, let's do a little diversion and talk about plus plus. Because this feeds, if you understand how it works, it feeds into some interesting ideas later. Not Java. So there are 4 things that kind of do the same thing. So let me just put that everywhere so that we always have the value. Okay, so what we're going to see here is I progressively becoming uh, 0, 1, 2, 0, 1, 2, 3, 4. So after the line 4, I is equal to 0, as we would expect. I equals I plus 1, adds 1 to I. Okay. I plus equals 1, adds 1 to I. I plus plus, adds 1 to I. So you can see it's gone from 0 to 1 to 2 to 3. And plus plus I adds 1 to I. So you might say, well, this is great and wonderful. Why do we have 4 different ways of saying the same thing? So there's certain subtleties in using these. And it's about what happens with the value. So let's do some interesting things. So the first 2 are easy. So this one is just a nice shorthand. That's all it is. Basically, if you want to write anything, so if you've got pretty much any operator, and you have something like value equals value, whatever the operator is, constant, well, it doesn't even need to be constant, it could be another value, you can replace it with v op equals u. So that's just kind of like a standard shorthand. So, you know, op is any of plus times minus divide mod and or no, there's no double and one. Whatever as appropriate. So that's not real code, so I'll just comment that out for the moment. Ah, hey Nick. Everyone say hi to Nick. Alright, so basically, I mean, there's a lesson here that lists, I think lists all of them. Streaming and recording and everything's killing my internet. Where did I put it? Yeah, in this one, the tidbits and trivia one. Yeah, there's a whole bunch of combined operators that you can use in Java. Of course, all the types still have to match, so you never get away from that. So I can't like times equals a string. I can plus equals a string because plus is defined for strings. I can't and equals an integer. Well, actually I can, but let's not talk about that. But it's, you know, normally you do that with booleans. I can't mod equals anything other than an int. Right? So you don't get away from the type restrictions of it, but you can write things a bit neater sometimes, or a bit shorter. Yeah, so I equals I plus 1 is just the same as I plus equals 1. This is exactly just a contraction of this thing here. So, of course, it doesn't have to equal 1. This can be, you know, 2 or 5 or whatever. It can be another variable. It can be anything. I'm just happen to be doing the increment ones here. So what are the other two? Well, we've got I plus plus and plus plus I. So on the surface, they seem to increase the value of I, and that's all well and good. But let me show you something else. So what happens here? Oh yeah, I'll come. So those who've spotted the lack of curly brace, I'll come back to that in a sec. So anyone want to take, say in chat, what is going to be the value of b and what's going to be the value of I? So I is starting at 0, and then I'm assigning b I plus plus. Oh, I forgot there's a delay. It's alright, I'll use that to pour some more tea. So we've got a vote for 0 and 0. Don't be afraid, I'm not going to make fun of you for getting it wrong. They'll both be 1, b is 0, I is 1. Okay, so we've got b is 1 and I is 0. And Nick is just putting in every possible thing. So we've got some idea that this is going to increase I by 1. Okay. And I starts at 0, and B is somehow related to the value of that. So we know that B and I are both 0 or 1. Probably I is 1, because we're doing something about incrementing I here. So after we've done that, we feel like it should be 1. So the question is, what happens to B? And you'll notice this is also one of the differences between these two statements. Right? So let's run the code and see. So we get that B is 0 and I is 1. Okay. But what does that tell you about what's happening here? So this increment of the I value isn't happening until after B gets its value out of I. Okay. So let's go and draw that. So let's see if I can make this make sense. What color am I on? Black. So I've got the value of B and the value of I, and I've got, so we're pretty clear on this one. This sets I to 0. So at that point, when we finish that line of code, that gets us to here. Good. But then we've got this line of code. And what we end up with is 1 and 0. Okay. So maybe we can break this down a bit more, because there's two things happening here. We've got increment I and assign value of I to B. So there's two steps going on at the moment. And the question is, which order do they happen in? So from our result, we should be able to tell, right? So this happens first. And this happens second. Secretly, what's actually happening is that when it evaluates this expression, it has to choose whether to get the value out of the variable first and then do the increment, or do the increment and get the value out. So when you've got I++, it gets the value out, stores it in a temporary spot, increments I, and then returns the value that it retrieved. But we can always think of it as doing it in this order. So it's more like this code is actually breaks down into that. So let's look at the other one. Where did my code window go? There it is. So if I comment that one out and do int b equals plus plus I, what do we expect here? So probably, well, hopefully after that you've got the right thing, or at least got one guess. Instead of this, Ooh, black. There we go. I don't know where the move button is. Oh, forget that for the moment. Just make a new one. So we have the same start, and we end up with I is 0. And then we've got int b equals plus plus I. So if before we ended up with 0 and 1 and the choice was between incrementing or assigning first, then you may guess that what happens in this one is that it breaks down to code that looks more like this. Oops, nope, wrong way around. And this pick black. There we go. Would give us the values 1 and 1. So this one is the increment first. And this one is get the value first. So they both do two things in that they both increment I and they both return the value of I, but this one gets the value first, or gets the value first and then increments it and returns that value, and the other one increments it first, then returns the value. So let's run the code again and hopefully confirm that. Yay! I got it right. Imagine if I've been teaching this programming this long and went, oh, it works this way, and oh no, it doesn't. My God. I've been exposed. No. Okay, so you can see that this is a useful distinction. Well, hopefully you can see it's a useful distinction, because you might want to do different things with this value b, because maybe b is going to preserve the previous value of I, or something like that. Or it's not in this case, you want to increment it first. But what's the other useful thing about this? So these two lines of code are kind of a giveaway. Because you'll notice that here the plus plus I and the I plus plus, well, okay, on lines 15 and 17 appear just as statements by themselves, and it works fine. But on lines 20 and 24, they appear as expressions inside a bigger statement. So I can, well, I don't want to say hide exactly, but I can insert an increment of a variable, as long as it's an int, or a short or a long or whatever. But as long as it's an appropriate type, I can hide an increment inside a bigger statement. So I can kind of do two things at once. Or I can do a whole bunch of things at once. So let's look at something dumb. So I can do I have no idea what the utility of doing something like this is. But I can quite happily mix and match a whole bunch of things like that, and I can modify variables as I go. And how I modify them changes what the value of C is going to be. So I won't go through all the options here, I won't even bother printing it out, but you can see that I can mix and match it. But there's no way I can do it with this, right? I mean, I can break it down into the different statements, but I can't put this on the right hand side of anything. I can't put in here C equals J equals J plus 1. So just as a proof, actually need to compile it first. Fine, it's going to compile on me. Wonder if I can do it here. Oh wow. Okay, there you go. I just ruined everything. Oh no, sorry, hang on. There we go. So I just unveiled a weird little quirk. You can do chain assignments, but once you've got something in the middle like this, basically you can't figure out what to do with it. And it comes down to essentially the typing and the fact that we kind of don't know what's going on here. So I wonder, let's try doing a few things. So I can kind of fiddle around with these and stick them in. Now I want to know what C is actually. So C comes out as 2, J comes out as 1, and... Sorry, J comes out as 2, K comes out as 1, and C comes out as 2. Let's see if I can figure out how that's actually even happening. So, well, I mean, it's actually not that hard to figure out. But before I get there, you can see that this is much, much uglier and harder and easier to mess up, or harder to understand and easier to mess up than J++ and ++J. Because, I mean, write this line of code, what the hell is going on? This is just madness. And I'm pretty sure you can easily imagine that you can stick in all kinds of stuff. So you can see this little thing here suddenly becomes a very useful little tool. Because sure, you can apparently stick this in the middle of an expression if you do the right thing, but it's pretty dicey. A little side note, you never used to be able to do this in Java. This is a relatively recent addition. So, unraveling that for anyone who's going on. Figuring out what's happening here. So the first thing that happens is this assignment, because it's in the parentheses. Then this effectively gets... I don't know how to indicate it without messing up the code. This effectively returns the value of k. So what you get here is j is equal to j plus 1 plus k. K is 1, so j equals j plus 2. And then the value of j gets assigned to c. So it's decipherable, but it's not great, right? But it's a pretty good lesson in a sense, in that there are lots of things in programming where you can do it lots of different ways, but some of them you really probably shouldn't. Interestingly, it does show you that everything in Java still has a type. This assignment statement still has a type of int, because it quite happily gets added to all of these as an int. So essentially, the thing that this gives back is k, or the value of k at least. Okay, so that's a diversion. Oh, the other thing that I do want to say about this, the other advantage of these ones over the short increment ones is that this doesn't have to be 1. Alright, so if I had k++, I can't do that. There's no, well, I mean, I can write k++++. I can quite happily write that. Well, I don't know about happily, but I can write that. Did I count right? Invalid argument. 1, 2, 3. I've forgotten how to bracket this to make it work properly. Oh, not important. But I can try and do that, and then I can mess around with this thing, and you can see it's not a great way of doing it. So if I wanted to do this, that kind of approach is, I mean, I'm not going to say the only way, but a much more effective way of doing it. Right, so again, each of them is a tool, and you have to learn to use them sensibly and use them usefully for what they do. It's not that one is magically better than the other. Yeah, so that should work, right? Sorry, I just want to... I'll think about that. Not important right now. Okay, how are we going for time? Alright, so someone else noticed that there's no brace here. Oop, don't want that there, I want that there. So I can quite happily put the brace in, but Java will allow you, well, not just allow you, Java is quite happy if there is a single statement for you to leave out the braces. So you can do it with loops as well. So this loop can be written like this. So if there are no braces, all Java does is grab the statement that comes immediately after it, and that's the whole contents of the loop or the if or whatever. Which is where you get this error from. So if you accidentally, probably reflexively, put a semicolon after the for statement, it goes, oh, here's an empty statement. That's the entire body of my for loop. The same as this one. I can put that there and that'll work fine. So let me just clean that up. I mean, it won't work fine, but this will compile. And it will run until I put that in and we get the exception that we saw before, and hence prompting me to put that in. So this is a thing you can do, use it wisely. Typically it is preferable to put these in anyway because it's much harder to make a mistake if you do that. So if you've got the open and close brace, you're very clear about what goes in there, and if you want to change it later, it's easier to add other code as well, because you don't need to then add the open and close brace because they're already there. And it also, with the indenting, more clearly indicates what's in the if statement. So you can do it, but be careful doing it. It's a good way to mess things up. Okay. Sorry, just catching up with the chat. Yeah, okay, you can do horrible things with the operators. um, okay, so in the last half hour, let's talk a bit about methods, because they're probably going to take a little bit to maybe get used to. I mean, those who get them straight away will get them straight away. But they're like this stuff we're seeing with the arrays and the loops. You can pretty much write anything you want now. It'll just be really ugly. There's an awful lot you can do with just arrays and loops. But if you want to write something that's anywhere near halfway decent, you're going to need methods. And as you get better at programming, you'll find more and more of your programs are basically just a collection of methods that call each other. You write very small, compact methods that do a defined job. And then, again, you're much more certain that the method is correct because it's small and it only does one thing and it's kind of clear what it does. It can be tested better because it is clear and defined in what it does. And it's easier to be reused because once you've written it, you can use it anywhere that you make it available to be used in. So, let's start by pointing out that you're in fact already using a bunch of methods. So, this main method here, and the name is a giveaway, is a method. It has a special function in Java in that when you run the program with Java whatever, this is the thing that it goes looking for in that class. But other than that, this is just a normal method. It follows the normal structure of methods. It can in fact be called from other methods if you really, really want to. Usually not a great idea, but it can be done. It has the same syntax. Other than this one little special thing, which is kind of external to it, it's just a normal method. This thing here, print, is just a method. NextInt is just a method. Println is just a method. Close is just a method. Right? So you've already been using these things over and over again. So the use of them, you should be fairly used to. It is basically a thing where you can say, I'm going to give you some information, maybe none. So this gives, you don't have to give it anything, but you give it what information it expects, and it does something for you. And that's the whole point of them. They are a thing where you have a clearly defined set of information that you give it, you pass it in, it does whatever it does, and if it's appropriate, it gives back a piece of information. So this nextInt method takes in no information, but gives you back an int that comes from the keyboard. So the fact that it comes from the keyboard is defined up here. So system.in is effectively the keyboard. And at a high level, that's basically it. So what's an interesting method? Well, not an interesting method. What's a boring method? So let's write a really simple method. So I'm going to write a bunch of gobbledygook here, and I'll explain some of it by the end of the lecture. We'll see how much time it takes. So this is our standard boring check if something is even test. Chosen because you've all seen it and you should know how it works and you know what an even number is, so hopefully you're not caught up on what it's actually doing. But this thing here that I've just written is a method. So it is a clearly defined piece of code that gets clearly defined information in and gives back a clearly defined single piece of information. What it does in between these braces is mostly up to the programmer. All right? Whether it actually computes whether it's even or not is up to the programmer. But hopefully it does what it says on the tin, otherwise you're just being a jerk. But again, like oversimplifying things, that's really all methods are. They're a piece of code where you can say, well, I know what information I need to do this little piece of computation, and I know what it's going to give back. So I'm going to encapsulate it in this syntactic structure called a method so that I can use it whenever I feel like it. So let's put So modifying my program a little bit here. I can put in which index I want to see and find out whether it's even or odd. Of course, that's a very boring result because we already know what it is. So if I put in -1, we'll finish that. But hopefully this illustrates just a little bit how the method works. So what happens when Java hits here is that it takes this piece of information, or however many you give it, because you can give it more than one, finds this method, jumps to that method wherever it is. So it may not be in the same class. So you can see here I've defined them both in the same class, but that is not necessary. And in fact, you know, this is not in the class, that's in some other class. So they can be all over the place. Creates this variable, in this case, inside the method it's called n. It doesn't exist outside the method, it's entirely local to this method. Gives it whatever the value of this thing is. Then does whatever computation it is, and if it's got a return type, it gives back some value, hopefully according to the computation, but you know, it's not compelled to. I could just always say that everything's even. It's not a good idea, but I could. So between this and this and this, you've got the rough basics of what a method does, right? It takes in some information from the code, from somewhere else in the code, sets up those variables with that data, does some computation, and then gives back a piece of data of whatever type that you've specified. So you can see here it's a Boolean because I want it to be true or false. So if this is even, so if it's true that the value stored at A subscript J is even, then do whatever I say here. If it's false, that implies that it's odd. Do whatever I say here. It doesn't have to be a Boolean, of course, it can be any type. And we do have a special keyword for when we don't want to return anything, and you've already seen that lots and lots, and that's void. So you can see that nowhere in this main method, and nowhere in the main methods that you've seen before, do you have keyword return. So what's called a return statement, I should say. Because this is a special thing that says this method doesn't give back anything, so don't go looking for a return statement. If it does give back something, you have to have a reachable return statement. Right. So let me do this. So if I try and compile it now, hopefully that's a small enough change that you can see I get a missing return statement error on line 7. So it's managed to, so it's not super clever, but if Java can't figure out a way that this method will always get to some return statement, then it will tell you, well, basically I got to the end of this and I found a way that you can get from the start to the end without getting a return statement, but you said that there was a return statement, that this has to return something, so you have to go back and fix that. So obviously back to the thing, it'll compile fine. So the return statement is also where the computation of the method ends. So as soon as you hit a return statement, it evaluates whatever's on the right hand side here. This has to have the same type as this, and it gives that, stops the method and goes back to where you called it from. So if I try and put in this here, I mean, you can see probably the lint will complain about unreachable code. But you can see it says on line 7, this is unreachable, because there's no way to actually get to this, because the return statement stops the processing of the code in the method. Which is a useful thing as well, because you can use the return statement to stop at certain points. So once you've called the return statement, nothing else happens in that method. It goes back. Okay, so what else have we got here? So we've got two other purple words here. So purple in Ed's workspace, at least in the dark mode, means that it's a keyword. So this is something coming from the language, which means these are things that control or restrict or tell us something about the code that we're writing. So int is a type, boolean is a type. Here it's the type of this variable, here it's the return type of the method. So as a side note, again, everything in Java has a type. The type of this method is boolean, because that's the return type. So the first one we have on any method is the access modifier. So far you've only seen public, because the main method has to be public. That's just a stipulation for it to actually function. There are several access modifiers. I'm going to show you 2 of them. The rest are listed in the lesson, but I'm not. But we've got 2 basic ones. Not int, it. No, stop auto-correcting to int. So there's 2 intermediates, one's package protected and protected. Don't worry about those for the moment. We might get back to those later. But this allows us to enact some control over who can run bits of the code, and eventually who can access variables, because we can have class level variables which have these modifiers as well. So I can put this here, which belongs to the class, and if it's public, another part of the code, wherever it is, as long as it's in the same program, can modify this variable, which may be what you want, but almost certainly isn't. But if I make it private, then only this class can modify it. roughly speaking. There are some exceptions to that, but nothing worth worrying about at the moment. So here, I can ask myself, where am I going to use this method? Is this a thing that should be available to everyone to use? Or is this a thing that should only be used inside this class? As a general rule, unless you have a reason for it to be available to other people, you should assume that it shouldn't be. Right? So unless you have a reason to make it public, you should make it private. That doesn't mean you shouldn't make some things public, but you should think about it first. So if you start off at private, then you run into less trouble, because if you never use it anywhere else, then you've lost nothing. But if you do use it somewhere else, you only have to change those ones. So a question from the chat is, how would you make sure that two classes are part of the same program? Basically, if they interact with each other. So let's So I know I just made it private, but it's a good enough demonstration. So you should see here the method is even from loops is not visible because either it's not there or it's private. But basically this means that now loops and inc are part of the same program. So there's more complicated ways of making things the same program, but essentially if they're in the same directory and they use each other, they're the same program, or parts of the same program. So let's just look at what happens when you, so say you made something private and you didn't mean to, you'll get an error here, is even has private access in loops. So that means things outside loops can't see it. If I make this public again, you'll see this error goes away. And I can quite happily run this, and C is true. So the value of C was 8. Oh yeah, because I put the 7 in there. And I hopefully we all agree that 8 is an even number. Yeah, so to follow up on that, as long as the files are in the same location, Java will find it. You can actually provide paths, and there are ways to put things in packages and modules and sort of group them together and tell Java that you want to use that package or module. But we don't need to worry about that until I think you see it at the end of programming, applications programming, maybe. But technically you have actually seen it already. So for example, java.util is a package. So if you've got something in another package, the way that you bring it into your current program is with this import statement. So that's what import does. It says go to the big Java package, the util sub package, and get me the class scanner. So you can do that with your own code. If you've got your code in a package over somewhere off screen, you can say, you go to that package, get me this class, or get me everything, or whatever. But now these are both part of the same program. They're not just files in the same directory anymore. One uses the other and it's part of the same program. Just as a side note there, notice that it's only using the isEven method. So there's nothing that says you have to use all of a class to do it. So it doesn't run any of this code at all. It takes the value, again, exactly the way methods work, it takes the value of C, gives that value to the local variable n, does whatever computation it does, and returns a boolean. So in this case it checks whether it's even, and it returns back to the point that it was called from. So it doesn't jump around the rest of the code or anything, it goes into the method, finishes it, and goes back to where it was called from. You can call methods from other methods. Again, you've been doing that already. Main is a method. You're calling println here, that's another method. Println calls a bunch of other methods that you don't see in the background, but it does. Here I'm calling println and giving it information from another method call. So these things can all be chained together in complicated patterns. And I mean, that's essentially what programming is. It's taking these things and chaining them together in complicated patterns. But that basic ability to call a method from another method gives us the tool called recursion. So if you haven't seen recursion before, but you've been on Reddit Programmer Humor, you'll see everyone's scared of it. It's not actually that scary. It's just a good way to get some fantastic errors if you do it wrong. But recursion is our other basic tool for iteration. So once again, drawing it back to the very, very start of the subject where I said there's 3 things that you need for a programming language to be essentially useful, which is some notion of state and a way to manipulate it, some notion of being able to make a choice, branching, whatever you want to call it, and some notion of repetition. So state in Java is basically encoded in the variables. Again, it's a bit more complicated than that, but for our little view at the moment, that's good enough to think of it like that. Branching is done with things like if statements, so anything where you make a choice, and our if statement's our basic thing there. And for repetition, we just saw loops. So loops were a way of repeating pieces of code, but methods are also a way of repeating pieces of code, and recursion is a way of making that work on more than just a single layer deep. So recursion is a different method of repetition. It turns out that, at least in the most general case, looping and recursion are just as powerful as each other. So again, it's a bit like a for loop and a while loop. Really, in the background, there's no difference between them, but they are suited to different problems. So we won't really deal with recursion in this subject, so don't panic about it, but just know that it's a thing that can exist. Maybe I'll throw some recursion ones at the end. Just as some exercise to get people to used to it. So the last thing in the method that I haven't said at least something about is this static keyword. So main has it, and the one I created here has it. So this is where, how much time we got? 7 minutes. Yeah. This is where we need to talk about how Java handles memory. So this will definitely be fuzzy, especially the first time you explain, or it gets explained to you. But you don't really have to super understand it well, but you kind of have to know it exists. Eventually, as you do more programming, you'll get more and more used to it, and you'll be fine with it. But at the moment, this is going to be, unless you already know it, of course, this is going to be one of those things where it's like, sure, okay, I believe you. But the way memory looks in Java is that you have a thing called a stack and a thing called a heap and a thing down here, which I am going to call the source code, which is not the actual name of it, but that's all I care about at the moment. It's called the program area or something like that. So this one gets sort of local variables and stack frames. You don't need to know what a stack frame is, but it'll come back to haunt you later. And the heap is where object variables are declared. Variables. Or reference variables. And the source code is where the source code is. So if we go back to our code, well, no, I've got the, so down here we've got loops, which has on it a method called isEven. So if I want to call this method, at the moment, because we haven't created any objects of it, it only exists down here, right? So I need a way of accessing it, and that's exactly what the static keyword means. So the trade-off is that that is the only copy of it. So for a method, that doesn't make a massive amount of difference necessarily. But the no, I'm about to confuse things with something that's not quite true, so I won't say that at all. But essentially, you can think of in the source code is the class itself. So this is not strictly the correct way of thinking of it, but you can think that basically in the source code is this file. Right? And there's only one copy of that file and it sits there. So if I put something as static, then I can access whatever that thing is. So I've said loops has a method called isEven, and I'm going to say that it's static. So that means you can call it from down here. So essentially anywhere in the code, because in some sense the code runs on the stack, I can do loops.isEven 5, whatever it is, and that will go, oh, I know where to get that, that's static, I'll go down here and look at it. If I create, so something that we've done but we haven't really talked about yet, if I create an object of type loops, so if I go loops L equals new loops, what this does here is create a variable called L that has type loops, and its value is a reference to a piece of memory over here. And this has whatever it is loops needs to function as an object. Right. So this is an instance of the class loops. So if anything is not static, then it looks here. So static means go and look on the actual class definition for it. If it's not static, then it has to look on a particular object. So an example of that we in fact already have in front of us is the scanner. So this scanner variable sc is a variable of type scanner that points to a piece of memory on the heap that contains whatever information it is a scanner needs to function as an object. We don't know what that is. I mean, one thing is obviously it needs this piece of information, the location of system.in, whatever that is. But you can see here, this method nextInt is being called on the variable, so on the object. So that is being called over here on the heap. So I've got, no, horrible green is a bad idea. So I've got sc, which points over here, and then it says I should have used my thing here, but it's calling nextInt from over there, basically. In this piece of code, you can see I've got the class name, loops. And in fact, we've seen that before as well. So system.out is retrieving the out object that is on the system class. So when I've got the class name instead of a variable name, it says, oh, I should go and look down here in the source code spot in memory for what I meant to do there. And to be able to distinguish between whether that's allowed or not, what we do in Java is say, if it's static, so like the main method or like isEven, then you can look at it from down there, and you don't need to create an object of that type to be able to do it. If it's not static, like nextInt on scanner, then you need to create an object of that type first. So I need to create this variable scanner, which points to an object of type scanner on the heap, and then on that variable I can call that method or do whatever it is I want. Okay, so you've seen the basic introduction to methods there, and that piece of information about the memory is enough to confuse you. So I'm going to stop there for the moment. I think we've just hit our time anyway, so it's a pretty good place to stop. So like I said, that'll probably be pretty fuzzy. Let that settle a bit. Go and read and watch the lessons about it. Come back to it. We don't need to deal with it for a couple of weeks. So this is a thing that can simmer in the back of your mind, which is why I want to introduce it now. But other than that, I've got a couple of minutes to answer some more questions, and then I'll let everyone rush off to their labs and have a good weekend. So that's a good question from the chat. So if I make a class variable, let's make one here. Static int x equals 10. So this one variable is effectively stored down here in the source code. Strictly speaking, that's not actually where the value of the variable is, but as far as the sort of the abstract view of the high level view of stuff is, it's stored down here in the source code. So that means every object of that type and every other piece of code in the code base, when it tries to get that variable, this variable x, gets it from down here. So it all shares the one copy of that variable. If it's not static, then every object gets its own copy of that variable, and it's up here in the heap. To those who are submitting the assessment task in week 4, it's not checking off on the side for some reason that I haven't figured out yet, and I will work out what that is and get back to you. So don't worry about now. It's recording the submissions. That's all right. Are there any other words for static? No, not in Java. You can sort of call it like class level stuff and object level stuff, but it's not. That's just sort of hand waving. All right. Thank you everyone for turning up. Let me stop the recording first. All right. Oh, so the assessment task, so in the week 5 lab assessment. So it's still recording the submissions and they're ticking it. People are passing the tests fine or failing them as appropriate. But for some reason in the slides part, it's not putting a green tick there, and I don't know why. But yeah, don't worry about it too much. It'll be fixed soon when I figure out what magic checkbox that I have or haven't ticked. All right. Well, yeah, the required stuff. So I'll talk to you all soon. Have a good lab for those who have their lab. Have a good weekend. I'll see some of you on Tuesday and the rest of you next Friday.